you want to design a multiplexers, but you have the size of the multiplexer is only at present you have only the small size multiplexer called 2 by 1. Is it possible to implement this with the higher order? Means yes, you can combine so that it will become a higher order multiplexer. So the first question is multiplexers is used if you combine two lower multiplexer, so that you will get a higher input multiplexers. So here, initially at present, whenever you're designing something, the lower multiplexer is 2 by 1, let us suppose. Okay, so but I, with the help of this 2 by 1, I want to implement 4 by 1 multiplexer. So what I have to do? So first step is see here. In general, to implement B by 1 multiplexer using A by 1 multiplexer, one formula is to be used to implement. So is it visible, my screen? Is my screen visible?
Yes, ma'am. Yes.
Yes, ma'am.
Okay. So this is your higher multiplexer. This is your lower multiplexer. Higher, let us consider some value. But what is the formula? How to generate, so that how can you know that these many 2 by 1 multiplexers are needed to construct 4 by 1 multiplexer? So you have to follow some rules. So these are the formula that you have to use in order to know the steps. So first is B. Let us consider B is a required multiplexer. So let us consider the required multiplexer is 8. So the required multiplexer is, let me go for simple, 4. Okay, so 4 by 1 multiplexer, but you have presently we have 2 by 1 multiplexer. Let us consider. Okay, so here what we have to do is see, B is considered as, this is the required, we need this, and required by available. Okay, so here we have 4 4 by available is 2, so you will get 2. Okay, next is what, you want to implement 4 by 1 multiplexer using 2 by 1. So B is here 4, A is here 2. So what we have, 4 by A is 2, so 4 by 2 is, you will get 2. So next again you have to take this result 2 by the available multiplexer 2, so you will get what? So the available this has to be taken as a result, not the required one. So 2 by next 2, you will be ending with 1. Okay, so until how many times you have to do, means until you reaches to 1, so you have to stop. So let us consider I want to implement 8 by 1 multiplexer using 2 by 1. So first is what, the required is 8, available is 2, so you will get what we will get?
4.
4. Okay, next, should we take a required or the resultant one?
Resultant 1.
So the resultant one we have to take 4 by 2. What will get?
2.
2. Again this resultant one we have to take 2 by 2. So we will get finally 1. This is your answer. Okay. So in order to represent, so how many 2 by 1 multiplexes are required if I want to implement 4 by 1 is, you try to add. So 2 plus 1. So this is your 2, this is your 1. So finally you require 3 2 by 1 multiplexer to implement 4 by 1. So similarly, how many 2 by 1 multiplexers are required to implement 8 by 1? Yes, this is 4, 2, 1. So 4 plus 2 plus 1, which is equals to how many we require, ma'am? So total how
7.
many 7 we require. Okay. So total 7 we require 2 by 1 multiplexers in order to implement higher order 8 by 1 multiplexer. Okay. Now how to do is, this will be considered as a first stage. This will be considered as a second stage. Means what? First stage we have to use 2 by 1 multiplexers like this. 2 inputs will be there, 1 output will be there, 2 inputs will be there, 1 output will be there. Selection lines will be how many, ma'am? Selection
1.
lines 1. Okay, so in the first stage, this is your first stage. second stage, third stage. In the first stage we have 2, so we have represented 2, and in the second stage we have 1, so we have to represent with 1 with 2 inputs. You have to take this 2 as inputs and 1 output. So this is your stages. So in the similar way, in order to implement 8 by 1 multiplexer using 2 by 1, so in the first stage we have to implement with 4. 1, 2, 3, 4. Next, in the second stage we have to use 2, and in the last stage we have to use 1. So this even not even informs the count number of multiplexers that we have to use. Along with that, this sequence, it also gives a number of flip-flops that you have to use in each stage. So this is your first stage, this is your second stage, this is your third stage. So in this way we have to implement. Let me start with 2 1. Let me start with 2 by 1 multiplexer. Using 2 by 1 multiplexer, I want to implement 4 by 1 multiplexer. So for that, what I have to use is, in the first stage, how many I have to require? 2 or 4?
2.
2.
Okay, 2. So 2 I require. 2. Next one is in the second stage?
1.
1.
1. The size that we have set, the available multiplexer we have is 2 by 1. 2 by 1. So it has to work as 4 by 1. Is it or not? Let me check. So you will be giving 2 inputs. This is also 2 inputs. 1 output. This will be passing as an input for the next multiplexer. This is your output. This is your output Y. Okay. So selection line here you will be having 1, 1, 1. So see here, ma, just first to see the how many selection lines should be present for 4 by 1 multiplexer first. How many should be there? 2.
2.
Do we have
2.
2? Yes. This is 1. So if it is in the same stage, we need to consider as 1. So this is 1, 2. So we have 2. Yes, it is working. Now what will be the input for this case? Yes, not. Yes, 1, 2. Based on the selection lines, 0, 0, 0, 1, 1, 0, 1, 1. Okay. So the output will be selected. If it is 0, 0, I naught will be selected. If it is 0, 1, I1 will be selected. If it is 1, 0, I2 will be selected. If it is 1, 1, I3 will be selected. Let me write here also. I0, I1, I2, I3. Even you can write D1, D2. It depends upon what we are selecting the variable name. Okay. Now is the first question that I want to implement this. And I need to get here I0. So here this is 0. So if there are two combinations, two inputs will be there, 0 and 1. If you applied here 0, 0 will be selected. If you applied here selection line as 1, 1 will be selected. So let me give here 0. Okay. So if 0 means what will be the output, I0 or I1? Selection line, if I am giving 0
I
for
not,
this
I
2 by
not.
0. I not.
I naught will be the output. Okay. So if I place a 0 means, can I place here 1? If it is in the same level, this will become what? 0 only. So what will be output from this? 0 means I2 will be selected. 1 means I3 will be selected. So I given 0. So which will be selected?
I2.
Oh, I2. Okay. In this also 0 means I naught will be selected. 1 means I2 will be selected. Simple logic, ma. So two are there. 0 means first one. 1 means the second one. So here I want to play 0. So why? Because 0. Try to concentrate. So I am placing 0. So if I am placing 0, what is the output that I am getting? I naught.
I not.
I not.
Okay. So still now I have not decided which one is just not or which one is just one. Based on this output, you need to decide and you need to tell me the answer. For the first one, both are 0, 0. We cannot give the status for this yes not or yes one. Let me go for the other option. Let me go for 0 1. Okay, so first 0 1 means, first of all, your target is you have to reach I1. It you, final output should be I1. Mm. If it is I1, what I have to place here to get I1? Is it 1 or 0?
One.
1.
1. Okay, good. So here also I have to place 1, here also I have to place 1. Okay, so means the output we will get from this is I1, from this is I3. Okay, next is what the output should we have to get is I1 or I3? I1, so I
I1.
have to place 0.
0.
So you will get I1. Now, based on the, let me give the previous one, we got as 0, 0, and here also we got 0. So, for the previous case, we have given 0, and for this also we have given 0. We got the output as I naught. Okay. For present case, we have given for the first stage as 1, and for the second stage as, in order to get I1, we have we given 1 or 0?
0.
0. So we got I2. So based on this, which one is the S1, which one is S0? Tell me the answer.
First one is not, ma'am.
First one is
It's not.
yes, good answer. So this is your S0. This is your yes not. Why? Because we are changing from 0 to 1, 0 to 1. So this is working as 0, and for the second one, if it is 1 only, you are getting output as I1. So this is yes not, and this will become yes 1. This will become yes 1, yes not, and yes 1. Okay, so whenever you are writing, try to concentrate. This will become your least significant bit, this will become your most significant bit. In this case, this is your least significant bit, this is your most significant bit. So based on the operations that you're, for example, if you're writing like this, yes not, yes one, here will be different. You have to write yes one, yes not, if in reverse way. Yes one, yes not. So you try to trace out so that you can understand what is going on inside. Okay, so in this way, let us go for the other option also, I2. So I2 means what? S naught must be 0. So is it working or not? Let me consider. So if it is I2, you want I2 means here definitely you have to place what? 0. 0. So if you are placing 0, in this I naught will be selected. In this, which one will be selected?
I2.
I2 will be selected. Okay. So I2 will be selected. Now, so what I place here for yes no, I placed 0. Now I have to get what? 1. So 0 0 completed, I have to get 1. So in this case, we have to give 1. So if it is 1, you will get I2. Okay. So in this way it works. So is it working as 4 by 1 multiplexer? Yes, it is working as 4 by 1 multiplexer. So let me show the diagram so that even more clear. First, everyone write down the steps. In general, to implement higher multiplexer using a lower multiplexer, one formula to be used is the one, this is the one. Required by available. So required is, let us consider 4, available is 2, which you will get one value. That value again divided by available, you will get one value. Until how many times you will divide this? Until you reach 1. Okay, till we obtain one count of multiplexer, then you stop. Okay, and how to know the number of multiplexers, how many 8 by 1 multiplexers are required is, try to add all so that you will get the total number of count. But how to know in each stage how many have to be used? Based on the first one decides the first stage, the second one decides the second stage, the third one decides the third stage. Let us consider third one is a count is equals to 1. Okay, so in this way you will do. Now everyone, okay, so write down side heading. Using 2 by 1 multiplexer, try to implement 4 by 1 multiplexer. So to do that, follow the steps. Follow the steps. First is required 4, available 2. So required 4, available 2. So 4 by 2, you will get 2. Again, the resultant one divided by available, you will get 2 by 2, you will get 1. So first you have two, so you will be using in the first stage two multiplexers and ended with one. So in the next stage you will be using one multiplexer. So here in the same example what I explained, I naught I1 I2 I3, I naught I1 I2 I3. So see here yes not yes one, but here it is not written. So maximum of the students will do mistake here. If it is done mistake, then half marks will be gone. So see here yes not yes one, but in this case first will be acting as least significant bit. So yes not yes one. As everyone knows what is this E indicates. Can anyone tell me what is E is for? E is what, ma?
Enable.
Enable. So if enable equals to 1, then only whatever the input that we are passing, the output will you will get the output, or else output will be 0, or else output will be 0. If enable pin is 1, then only the input that we are passing will reach to the output, or else output will be 0. So by default for each and every combinational circuits there will be enable pin. Based on if enable pin is high, only whatever the input that we are passing, the output will be generated. So by default, enable pin will be used for each and every multiplexer. Next question. Want to implement 8 by 1 multiplexer using 2 by 1 multiplexer. Okay. Want to implement 8 by 1 multiplexer using small size multiplexer 2 by 1. So what we have to do, first step is what? Already that also I explained just now. So first step is what? Required is what? Required 8, available 2. So first you try to understand required by available. So required 8, available 2. Okay. So next you will get one result. This result, again you will get one result. This result divided by available. So finally you will get 1. So in the first stage we are using 4. In the second stage we are using 2. In the third stage we are using 1. Is it correct or not? Yes. In the first stage we are using 4. In the second stage we are using 2. In the third stage we are using 1. Okay. That is okay. Next. Tell me if it is 8 by 1 multiplexer, how many selections lines are required? If it is 8 by 1 multiplexer, how many selection lines are required?
3.
3.
Are we getting 3? Yes, we are getting 3. Okay. So this is your 8 by 1 multiplexer. Yes, not yes 1, yes 2. And this is your output. If it is 0, 0, 0, I naught will be selected. If it is 0, 0, 1, I1 will be selected like that. If it is 1, 0, 1, I5 will be selected like that. Okay. So see here, S naught is least significant bit. I already said that stage 1 will be acting as least significant bit. The last will be acting as a most significant bit. So that is the reason we have written in reverse way. We have not written as yes 2, yes 1, yes not. Just now we traced, we have written as yes not, yes 1, yes 2. We will trace this so that you can even clearly you can understand. But just tell me in the first stage how many 2 by 1 multiplexers I have to use?
4, ma'am.
4. Okay. Two, two. Two inputs, one output. One selection line. But I am not showing enable pin. It will be by default enable pin will be there. Next in the second stage, how many?
2.
2. This one has to be connected. This has to be connected. This one. This one. In the final stage, 1. Okay. Now let me trace with an example. So yes not is a least significant bit. Yes 1. Yes 2. Why? Because our target is required. So in a required we have our target is 8, required is 8 by 1. For this 8 by 1 we require 3 selection lines. I am writing the target, and whether it is working as this we will see. This is your output. So you will be having 0, 0, 0, Okay, so in the same way, see I naught will be selected, I1, I2, okay. Now here also let me write the inputs. Now I want to use this first one as an output. So 0 must be placed. If I place the 0 means all will be 0. 0. So what will be the output from this? I naught will be output. Okay. So next is one 0. Next is 0. So I naught will be selected. Let me write the, as already we revealed the what to write. So let me write. This should be what? Yes not or yes 2? This should be. Yes not
Yes,
or
not.
yes. Yes not. Yes 1. Yes 2. Okay. So here this is also yes not. This is also yes not. This will be yes 1. Okay. Now. So the output will be yes 2 is 0. So I'm placing 0. So finally I know the output will be I naught. Okay. So in the similar way, let me go for this one. Okay. Whether this circuit is working as 8 by 1, let me check. First is 1. S naught is 1. So here I have to place 1. So if it is 1, what will be getting the output now? If it is 1,
I1.
from this you will get I1. From this, if it is
I
1, we will be getting
I3.
I3. From this we'll be getting I5. From this we'll be getting I7. Okay. Next, according to this, S1 is what? 1. So you will be having 1 here and here also 1 here. If it is 1, I1, I2, which will be coming output?
I3 now.
I3. Okay. From this,
I7.
I7.
I7. Next, we have here what? 0. So if it is 0, which will be coming? I3 or
I3.
I7? I3. So in this way, you have to trace. Yes, it was working as 8 by 1 multiplexer. So we have implemented this using 2 by 1 multiplexer. Yes, it is working. Okay. Now note down this Alma. Note down and trace for everyone. Trace it for 6. The output 6. Trace it for the output 6. 110. Is it coming or not? Check once. Yes, ma. Traced. Everyone getting the answer?
Yes, ma'am.
Yes, ma'am.
Okay, okay, okay. Now the next question is, note down the question, ma'am. Hmm. Implement 8 by 1 multiplexer using 4 by 1. Implement 8 by 1 multiplexer using 4 by 1. Okay, so you try to answer, ma'am. Implement 8 by 1 multiplexer using 4 by 1. So there are two types of problems that will be arised in while doing multiplexers trees, ma'am. So the question is, you need to implement 8 by 1 using 4 by 1. So are you getting one? So first is required 8 and available 4. What we will get? 2.
2.
2 by 4. Are you getting one? What will be the
No,
value?
ma'am.
What will be the value? 2 by 4.
1 by 2.
Okay. So you are not getting one, right? The problem arises here. So that means if you are getting ended with one means there is no problem, you can implement easily based on the stages. But in this case, it is showing in the first stage you have to use two, but in the second stage it is not. It is not. But in this case, what you have to use is you have to use the other multiplexer. So see here. So see here, first two we are implemented easily, two. So we used two 4 by 1 multiplexer, and as we have zero point 0.5, so in this case as we got two outputs from this as one and this as one, so you will be having two. So based on that you can use 2 by 1 multiplexer. Okay, based on that two you can use 2 by 1 multiplexer, so this will be working. So if you trace you can get based on the input. If it is 0 0, I naught will be selected. If it is 0 1, I 1 will be selected, like that. Okay, so this is for based on this, if this is active or this is active, based on that the output will be selected. Okay, now what I already said, that multiplex of when we are going from when you are implementing higher order with lower order, I only have 4 by 1 multiplexer, I don't have 2 by 1 multiplexer circuit. So what I have to do is I have to use enable pin. Try to concentrate. I have to use enable pin. So see here, this is one case that you can do 4 by 1, but this is not exactly the final solution. You have to use all 4 by 1, but in 4 by 1 I have used which multiplexer, ma'am? In 4 by 1 I have used which multiplexer again?
2 by 1.
2 by 1 multiplexer in order to implement 8 by 1. So I don't want that. I only have a 4 by 1 multiplexer. Using this, I want to implement 8 by 1 multiplexer. For that, as everyone knows that in the first stage, we have two 4 by 1 multiplexers. So I'm using. So if it is 4 by 1, how many selection lines to 4 inputs will be there? 4 inputs
2.
for this also. 2 selection lines will be there. So 2 selection lines and one output. Okay, and one output. So this output I'm doing XOR operation. Let me show what is happening in this. So let me write the inputs. So we'll start with I naught. So if it is 8 by 1, how many selection lines you try to find out? The selection lines will be 3, but we have here only ended with 2. So what I am doing is try to identify. So how many combinations will get if it is 8? How many inputs will be there? How many inputs? 8 inputs. So it starts from I naught, I1, I2, I3. Okay, I7. So here I am writing as S0, S1, S0, S1. Okay, now the other one is S2. S2. So other one S2, that one I am giving externally as enable pin. Okay, I am giving externally as E enable pin. So this for this enable pin I am giving S2. Concentrate. For this enable pin I am giving S2, and this one I am giving not, and I am applying to this. Okay, that means try to concentrate. S2 is S not, S1, S2. S2 combinations చెప్పండమ్మా for 7. It will be 0 0 0 and 1 1 1 1. Is it correct? See here. So S2 is 0 0 0 0 1 1 1 1. Okay. Are you following, ma? I'm
Yes,
not writing entire truth table, ma. I'm not writing like this 0 0 0 1. Just I'm concentrating on only S2. Why? Because we have this 2. Don't worry about this. So given a 0 0, I not will be selected. Given a 0 1, I1 will be selected. Given a 1 0, I2 will. Based on that, it will work. But I'm concentrating on S2, which is selection line. This S2 I'm giving as enable pin. Okay. So if you are for S2, if you are giving 1, this will be active. Try to concentrate. Just now I said that enable pin is what? If enable pin equals to 1 enabled, then whatever the input that you are passing, the output you will get. So if it is 0, that means the output will be 0. And if enable pin is 0, the output will be 0. Now, based on this situation, S2 is initially 0. So I'm giving 0. So if this is 0, whatever the input that you are passing, will you get output or will you get 0 from
No,
this?
ma'am.
The output will be 0. Okay. Now if this is working, this should not work. Why? Because in this case, for the first 4 this has to work, for the next 4 this has to work. For that, what I have done, I have given an enable pin and I have given directly an S2. So S2 is 0. So if it is 0, what I applied a not. So if I apply a not, what will be the output from this not? If I'm passing 0 in from this, ma, okay, S2 as 0, so I'm passing here. This is also enable pin for this. Okay, so I applied 0. So after completing from this not, what will be the output?
1.
You will get the output as 1. So is it enabled?
yes,
Is it
ma'am.
enabled? Yes, it is enabled now. So let us consider in this case I am passing 0 0, means the output will be I naught, and in this case it is 0 0, the output will be I4. But as this is disabled, you will not get output, the other will be 0, for finally you will get 0. Okay, so in the similar way, 0 1 you will get 0 1, but this will not be selected. For all the 4 combinations, you will be getting as I naught, I1, I2, I3 until I3. No worry, you will be getting based on 0 0 means I naught, 0 1 means I2, 1 0 means I2, 1 1 means I3 will be selected. Okay, now this turn works. This has to be disabled, this has to be enabled. So to do that, already we have here 1. Okay, if this is 1, that means this will be converted to 1. We are giving S2 as an input for enable pin. So enable pin will be working based on the S2 output. Okay, so now it is 1. So if you're passing 1 here, what will be the output?
0.
0. So now is it enabled or disabled? Now it
Disabled.
is disabled. Now it is enabled. Okay. Now what happens if you give 0 0? Which side will be 0? Which side will be 1? I not see here. Now this is disabled. Why? Because now we are in this column. So there we are in this input. So what will be the input? 0 1 0 0. This is the input. So we have here 1. So if you pass this 1, you will be getting output as 0. So if this is 0, that indicates this is disabled. Whatever the input that you passed, finally you will get the output as 0. Okay, now I am passing based on these equations. You will get 4 combinations for 4 1 0 0 0 1 1 0 1 1. Okay, so if it is 0, I4 will be selected. So we are getting no problems. Why? Because the other side we are disabled anyhow. Next is what? I5. So the next combination will be applying 1 0 1. So here will be 1. So if it pass here, it will be 0. So this will be disabled, this will be enabled, and the output you will get as I5. The other side will be 0. So you will get the output as I5. So in this way, next is 1011. So for all the cases, the S2 is 1. So this circuit for 4 combinations will be enabled, for 4 combinations will be disabled. In this way, we have to design using 4 by 1 multiplexer to implement 8 by 1 multiplexer.